Assalamualaikum warahmatullahi wabarakatuh and a very good day. So today I'm going to show you the example of 4.41 which is in your textbook. You can also refer the way of calculation in your textbook. Okay, so this is an example for multiple stage processes and non-reactive process. Okay, so for the multiple processes or units, basically the way of calculation is similar with the single unit. It's just that you have a bit additional of calculations. Okay, so similar with the single unit, we start off with the drawing the process flow diagram. So in this question, they already gave you the process flow diagram. Okay, so now we are doing the calculation for the degree of freedom. So before we proceed with the degree of freedom, we do first the what we call as the boundary of the processes. Okay, so this is the additional info for the multiple processes. So for the boundary, we have several types of boundary. So we have a unit boundary and overall boundary. Okay, so for the overall boundary means that you need to consider the inlet and outlet for the overall processes only. Okay, so this is example for the overall boundary. Okay, so this is overall boundary means that we don't consider calculation for the stream number 1 and stream number 2 here. Okay, so now I proceed with the unit boundary. So I draw for the unit. So if this is unit number 1, okay, and then unit number 2, and then we have a mixture there, unit number 3. Okay, so for the boundary unit 1, so I draw the boundary for unit 1. Okay, and then I draw the boundary for unit 3. And then lastly, I draw the boundary for unit 2. Okay, so that is for the boundary. So once we done with the boundary, then we can proceed with the degree of freedom. Okay, so additional calculation for the degree of freedom. So we know that degree of freedom is unknowns minus the number of substance and the additional info. Okay, so now for the degree of freedom, first of all, we consider for the overall boundary first. So overall boundary, so whatever in is a red color. Okay, so what is the unknown for the red color? So this info is given. So info for this line is given. So info for this line is given, but we don't know the info for this line. Okay, so this one, the info is the M3, okay, X3, okay, and then 1 minus X3. Okay, okay, before that I put the unknowns for each components. Okay, so this one is M1, so X1 and 1 minus X1. Okay, and then M2, X2, 1 minus X2. Okay, so for the overall, so we don't know the values for the outlet stream at 3. Okay, so for our unknowns, we have two unknowns, which is M3 and X3. Okay, so the substance, we have two substance, which is substance A and substance B. So our degree of freedom is equals to 0. Okay, okay, and then we proceed for the next degree of freedom for unit 1. So unit 1, so just check whatever in and out from the box number 1. Okay, within the boundary here. Okay, so we have two inlet. okay, and one outlet. So we don't know the outlet for the unit 1. So we have two unknowns, okay. So M1 and X1. Okay, so this one is 1, sorry. Okay, minus with the two substance, which is A and B. So the degree of freedom is 0. Okay. Now proceed with the unit 2. So unit 2. So this is the unit 2. So this is the boundary of unit 2. So inlet, one inlet and two outlets. Okay. So what is the unknowns for the unit 2? We do not know the value for the inlet for unit 2 and also one of the outlet for the unit 2. So we have four unknowns, which is M2, X2, M3 and X3. Okay, and we have two substances, which is A and B, similar with others, and we don't have any additional information, so our unknown is equals to 2. Okay, and then unit 3. Unit 3, so for this one, whatever in through the boundary, okay, we have 1 and 2 inlet and 1 outlet. Okay, so we have four unknowns, okay, which is M1, X1, M2 and X2. Okay, we have two also substances, which is A and B. Okay, and then the unknown will be, degree of freedom will be 2. So why do we need to know the degree of freedom of each boundaries? Okay, because we want to know which can be start with the calculation first. So for those having less number of degree of freedom or zero degree of freedom, we can start doing the calculation for this part first. Okay, okay, compared to unit 2 and unit 3, means that the information for unit 2 and 3 is not enough for us to do the calculation or solve the material balance. Okay, so now I proceed with the material balance calculations. So because we know that overall and unit 1 can start first, then we start with the overall material balance first. Okay. Okay. Oh, sorry. Okay. Okay. So the material balance calculation. Now we start with the material balance calculation. So for overall boundary, yeah. For overall boundary. Boundary. Okay. So for overall boundaries, we have overall balance and also substance balance. Okay. So we start with the overall balance for overall boundaries. Okay. So it's different, yeah. Okay. So just look whatever in and out for the red boxes only. Okay. So in 100 overall plus with 30, okay, equals to out you ada 1, 2, 3, right? So 40 plus 30 plus M3. Okay, so 40 here, 30 here. Okay, so you get your M3. So your M3 is equivalent to 130 minus with 70. Okay, which is 60 kg per hour. Okay, so now we start with the substance balance for the overall boundary. So I do the calculation for the A balance. Okay, so a balance for the overall boundary. So 0.5 times with the 100 plus with 0.3 plus times with the 30 equals to 0.9 times with 40 plus 0.6 times 30 plus x3 times with the M3, which is 60. Okay, so you get your x3 equals to 0.0832. 33 kg A per kg. So automatically you get the 1 minus x3, okay, which is equivalent to 0.917 kg B per kg. Okay, so that is a calculation for the um, overall boundaries. So now we can start for unit 1. Okay, because the unit 1, the degree of freedom is also 0. Okay, okay. So I erase for the material balance overall boundary. Okay, so the material balance for unit 1, yeah, for unit 1. Okay, so for the unit 1, so the overall for the unit 1. So just have a look on the unit 1 boxes. Okay, so overall calculation 100 in equals to, you have two outlets, 40 plus with M1. So you get M1 equals to 60 kg per hour. And then we can do the A balance, okay, for unit 1. So 0.5 times with 100 equals to 0.9 times with 40 plus with x1 times with the m1, which is 60 here. Okay, so you get x1 equals to 0.233 kg A per kg. Automatically 1 minus x1 is equals to 0.767 kg B per kg. So you already solved now M3 and M1. Okay. So once you obtain the value for M1, you can solve the value for M2. Okay. Okay. Or once you obtain the value for M3, you can also solve the value for M2. You can choose either you want to do the calculation for unit 3 or you want to do the calculation for unit 2. Okay, so if I am using the calculation for the unit 3 or the mixing point, in your textbook they state the mixing point, okay? MB for unit 3, yeah? Okay, so overall, okay, so this one, so M1 plus with 30 equals to the M2. So M2 is equals to 60 plus 30 equals to 90 kg per hour. Okay, so M1 just now we calculate 60, right? So we can do the A balance. Okay, A balance. Okay, so X1 times with M1. Okay, so 0.233 times with 60, okay, plus with the 0.3 times with 30 equals to x2, we don't know the value, times with the 90 m2, right? So you will get x2 equals to 0.255 kga per kg. So you will get the value for 1 minus x2 is equals to 0.745 kg b per kg. Then that will be the answer for all unknowns. M1 you already have, M2 and M3 parts. Okay, that's all for the multiple units. Thank you very much.